Something massive is shaping our universe, but we can't see it. Dark matter makes up 85% of all matter, yet remains invisible. Today, we're diving into space's greatest mystery and the groundbreaking discoveries that changed our understanding of the cosmos. Let's explore why dark matter is like a cosmic ninja. It's everywhere, but impossible to see directly. Unlike regular matter that makes up stars and planets, dark matter doesn't interact with light at all. It doesn't absorb, reflect, or emit any light. But here's the fascinating part. We know it's there because of its gravitational effects. Imagine a galaxy spinning in space. Based on what we can see, these galaxies should be falling apart because they're spinning too fast. But they stay together, which means something invisible must be holding them in place with its gravity. Scientists have also observed light from distant galaxies bending around seemingly empty space, another clear sign that dark matter is creating gravitational effects. These observations are like seeing footprints in snow. While we can't see what made them, we know something must be there. Dark matter isn't just floating around randomly. It's actually the architect of our cosmic neighborhood. Think of dark matter as the invisible scaffold that helps form and shape galaxies. When regular matter started clumping together after the Big Bang, it was actually following the lead of dark matter. Dark matter created massive webs and structures that regular matter naturally fell into, like water flowing into pre-made channels. This is why galaxies form in certain patterns and clusters instead of spreading out evenly across space. Without dark matter's gravitational pull, our Milky Way wouldn't exist as we know it. The stars would have scattered like marbles on a smooth table. Instead, dark matter acts like a cosmic glue, keeping billions of stars spinning together in their beautiful spiral pattern. Recent computer models show that dark matter forms huge halos around galaxies, like invisible bubbles that extend far beyond the visible edges. Now let's look at what scientists call the best proof we have for dark matter, the bullet cluster. This cosmic collision between two massive galaxy clusters showed something remarkable. When these clusters crashed into each other, the regular matter, mostly hot gas, slowed down and stuck together in the middle like two water balloons hitting each other. But the dark matter kept moving right through, completely unaffected. We know this because gravitational maps showed most of the mass passing straight through, while X-ray images showed the regular matter staying behind. It's like seeing the aftermath of two cars crashing, except one car passes right through the other without stopping. This discovery in 2006 was huge because it showed dark matter doesn't just affect things with gravity, it also barely interacts with regular matter or even itself. The bullet cluster became our strongest evidence that dark matter really exists as a unique form of matter. Scientists have tried to explain the universe's mysteries without dark matter, but these theories keep falling short. One popular idea was MOND, modified Newtonian dynamics, which suggested that gravity works differently at galaxy-sized scales. While this explained some galaxy rotations, it couldn't account for things like the bullet cluster. Another theory proposed that our understanding of gravity needed a complete overhaul, but this didn't match up with other space observations. Some scientists wondered if invisible gas clouds could explain what we were seeing, but the math didn't add up. There would need to be way too much gas. Even theories about hidden black holes or strange particles called neutrinos couldn't fully explain what we observe. Each alternative theory solved one or two puzzles but created new problems, while dark matter consistently explains everything we see. Let's meet the scientists working to catch dark matter in the act. Deep underground, in some of the world's cleanest labs, teams are using huge tanks filled with special liquids like xenon to try and spot dark matter particles. These detectors are so sensitive, they can pick up the tiniest energy signals. Think of them as cosmic security cameras waiting to catch our invisible culprit. In Italy's Gran Sasso laboratory, scientists work 1.5 kilometers underground to avoid interference from cosmic rays. Similar detectors in South Dakota are placed in old gold mines. The deeper they go, the better chance they have of seeing dark matter particles bump into regular matter. While we haven't caught dark matter yet, each experiment teaches us more about what it isn't, helping narrow down what it could be. These underground hunters remain optimistic. It's not a question of if we'll detect dark matter, but when. The universe isn't just a random scattering of galaxies. It's organized into an amazing pattern that scientists call the cosmic web. Dark matter forms the foundation of this structure, creating massive threads and connections that stretch across millions of light years. When we map thousands of galaxies, we see they form a pattern that looks like a giant spider web, with dense clusters connected by long filaments. Dark matter's gravity acts like a cosmic architect, drawing regular matter along these invisible highways. Galaxies naturally gather in places where dark matter is concentrated, creating the bright spots we see where web strands meet. Computer simulations show that without dark matter, this beautiful structure wouldn't exist. The universe would look more like a smooth, boring fog of stars and gas. This web-like pattern is one of the biggest clues that helped scientists understand how the early universe grew from a smooth ball of energy into the complex cosmos we see today. The Milky Way isn't just the bright band of stars we see, it's wrapped in something much bigger. Our galaxy sits inside a huge bubble of dark matter called a halo, stretching far beyond the visible stars. This dark matter halo is like a protective shield, about 10 times bigger than the visible galaxy. Its powerful gravity keeps our cosmic neighborhood together, preventing stars from flying off into space as they spin around the galaxy's center. Without this invisible force field, our galaxy would tear itself apart because it spins too fast. Scientists have mapped this halo by studying how objects move at different distances from the galaxy's center. They've found that the halo isn't perfectly round. It's slightly squished, like a football, and contains enough dark matter to equal the weight of 1 trillion suns. Scientists have two main ideas about what dark matter could be: WIMPS and MACHOS. WIMPS, or weakly interacting massive particles, are tiny particles that rarely interact with regular matter. They're like cosmic ghosts, passing through everything around them. MACHOS, or massive compact halo objects, are bigger things like black holes or dim stars that we just can't see well. Most scientists favor WIMPs because they better explain what we observe in space. WIMPs would have been created in huge numbers during the Big Bang and spread evenly through space. They'd be perfect for forming the cosmic web and galaxy halos we see today. MACHOS, while easier to understand, don't quite fit all our observations. They'd clump together too much and wouldn't spread out the way dark matter does. Let's travel back to the beginning of everything to understand where dark matter came from. Just moments after the Big Bang, when the universe was like a hot soup of energy and particles, dark matter was already there. Scientists think it formed before regular matter, in the first fraction of a second. While regular matter was still bouncing around like a cosmic pinball machine, dark matter started clumping together, creating the first foundations of structure in the universe. These early dark matter clusters became like cosmic construction sites, their gravity slowly pulling in regular matter to build the first galaxies. It's amazing to think that this invisible substance was essentially the universe's first architect, laying down the blueprints for everything we see today. Looking ahead, dark matter might hold the key to humanity's future in space. Some scientists think we could one day harness dark matter's powerful gravity to help spacecraft travel faster through the galaxy. Others suggest that studying dark matter could lead to new forms of energy or help us understand other dimensions. While these ideas sound like science fiction now, remember that a century ago we didn't even know dark matter existed. We're also getting closer to actually catching dark matter particles in our detectors, which could spark a revolution in physics. Understanding dark matter better could help us map safe routes through space, avoid dangerous cosmic areas, and maybe even figure out if the universe will keep expanding forever. The next few decades of dark matter research might completely change how we see our place in the cosmos. Thanks for joining me on this journey through the dark side of our universe. We've only scratched the surface of this cosmic mystery. If you enjoyed learning about dark matter, hit like, subscribe, and share to help others discover these amazing space secrets.